So my topic is Bluetooth Low Energy with ESP32 and MicroPython. So as you know, that Bluetooth Low Energy is used for wireless data communication with a limited range, but we can use that without wires. So as a solution for the wired communication, that Bluetooth implemented this BLE technology for mainly focusing on IoT projects during 2010. There are so I'm continuing with the BLE, and first we get an introduction about what is Bluetooth, and then after that there are two Bluetooth types, and we can take a little comparison about that, and we'll move to the BLE mainly. BLE about BLE project, how BLE works, and their frequency spectrum, and their architecture and device roles, and tools that we can use for BLE development. And also we can move to some simple projects that we can use using BLE with the ESP32 by coding using MicroPython in Thony. So first, as for the introduction, so Bluetooth is a short-range wireless technology, as I mentioned before. So it is in the range of 2.4 gigahertz ISM band, which is the international industrial, scientific, and medical band for data exchange. And there are two main types about Bluetooth, and one is Bluetooth Classic, and BLE. So we can discuss the differences and what we can use, what are the applications of those two categories in the next slide. And first we move on to the Bluetooth Classic. So Bluetooth Classic is the most familiar Bluetooth type that we use every day for everyday events. So actually, if you turn on the Bluetooth on your mobile phone, so you can see the devices nearby you that use Bluetooth Classic actually. Sometimes we have to use another terminals to track the advertisers of the devices that use Bluetooth Low Energy, but usually you can see them the devices that use Bluetooth Classic. So most of the times we use Bluetooth Classic for digital devices that for smartphones and for earbuds and other our day-to-day items. So but Bluetooth Low Energy, we use that for especially for IoT projects, and it is very customizable. So that's why the IoT projects is taking at BLE for data communication. And Bluetooth Classic was released around 20 years ago, but Bluetooth Low Energy released in 2010, and it was introduced in the Bluetooth 4.0. And Bluetooth Classic is not that much customizable, but Bluetooth Low Energy is customizable, and we can BLE developers can customize that according to their IoT projects. And another main difference is that Bluetooth Classic requires a lot of power for to transmit data, but Bluetooth Low Energy does not require that much power. So it is that's why it is more another reason for that. It is much suitable for IoT projects that runs on batteries. So it requires a lot minimum power. And both of the Bluetooth Classic and Bluetooth Low Energy are incompatible. So they cannot Bluetooth Classic device and Bluetooth Low Energy device cannot exchange their data with them, even they use the same Bluetooth. So they are not compatible. And for the Bluetooth Classic, we require a high bandwidth, and it is also sometimes not good for IoT projects. So in Bluetooth Low Energy, it does not require high bandwidth to transmit data. And that is the basic thing about basic comparison about Bluetooth Classic and Bluetooth Low Energy. So these are the main reasons that the customization about of BLE, and it is it does not require a lot of power to to communicate, and it does not require high bandwidth. So those things are especially helpful for IoT projects to run by using BLE. And as for so all the Bluetooth use frequencies spectrum for their data transmission. So BLE operates in actually the Bluetooth BLE and Bluetooth Classic, both of them operates in 2.4 gigahertz ISM band, as I mentioned before. So for the BLE, there are 40 channels that use 3 channels for advertising and 37 another channels for data communication. So I will explain what is the data, what is advertising. That is in Bluetooth in the upcoming slides. And another thing is for Bluetooth Classic, there are about 79 channels that use for data transmission. And also, as you know, that Wi-Fi also run in this operates in this ISM band 2.4 gigahertz. So to reduce that interrupt, there is a special mechanism for BLE which is called adaptive frequency hopping. That it changes. It doesn't have some kind of fixed ISM band between this range. It is always changing its band again and again. So it always change its frequency. So it avoid that overlapping with Wi-Fi, and it avoid that. So it is very useful for when it comes to BLE to connect a secure connection, and so there are BLE architectures that we that use in BLE communication. So actually, this is not that much need when you are starting with trying coding with ESP32 using MicroPython, and for to implement BLE in your project. But if you are trying to add Rise to your project, you need to know about those things. So in the Bluetooth architecture, there are some kind of things called host control and other stuff. This is come with the host part, and there are generic access profile called GAP, and actually that is used for managing advertising and connections. So basically, let me explain about the advertising part. We use that term before. So advertising means if you switch on your Bluetooth in your mobile phone, and you can see the devices that in your range, right? So in nearby, you can see the Bluetooth devices that mostly Bluetooth Classic devices that around you. So you can see the name of them. That is actually called what is called advertising. So the device using Bluetooth, we call it actually peripheral. So the device that use Bluetooth, it showcases that it is present to nearby devices that track the devices which has the Bluetooth. So in that case, our mobile phone becomes the central, and the other if we take a earbud, so earbud becomes the peripheral. So like this, so that is the all those advertising part is managed by this generic access profile, and generic attribute profile GET is basically the define how data is structured and the exchange where it should be structured before communicating. So that part will be done by GET, and there are some there are actually in Bluetooth data transmission, it uses a hierarchical data structure. For that, there is services and characteristics, something called services and characteristics. And the service is the collection of related characteristics. Actually, it is not going that much deep that we transmit, and a collection of that is called a service. So it is inside the BLE architecture, and yeah, that's all about the BLE architecture, how it's how actually the data is transmitted, and how the advertising part going on, and how we can find whether there is an device that use Bluetooth. So that part comes under this section, BLE architecture. And so there are, as I mentioned before, there are two devices in BLE. One is actually they are the roles that each device perform and at a time. So one is the peripheral, that is the device that that we connect with our mobile phone or laptop or any other thing. So it can be a, ESP32 smartwatch and IoT sensors. And the central is that the one who receive and one who see the advertisements that done by other devices that use BLE. So it is they are like smartphones, laptops, and BLE gateways. So likewise, so those are the main two categories of devices that when it comes to BLE data transmission. And there are seven is then RF Connect. Actually, this is used for as a debugging tool for BLE. It is not we cannot use that in throughout the project. You can just use that as a debugging tool. And there are other softwares and libraries that we can use to as a BLE to develop our BL project with BLE. So one is the MicroPython U Bluetooth. So BLE module. It is the BLE module that used in MicroPython for especially for ESP32. And there's another one called the Web Bluetooth API. It control that BLE via browser. And also there are some libraries in Arduino as well. Actually, in MicroPython case, it is a little bit hard to find resources in the internet related to MicroPython Bluetooth communication. So that's actually another reason that I choose this topic. So it is a little bit hard to find resources in the internet or any other place regarding using to connect device to power our IoT project with BLE using MicroPython. So and here I'm going to quickly explain you how to set up our ESP32 for BLE using MicroPython. And just let me share the screen. Okay, I hope you can see the new screen. This is the documentation that I did for BLE communication. Actually, this is the code that we should use to set up our ESP32 for BLE when you're using MicroPython. So here, this is the library that we use, import U Bluetooth. It is a MicroPython library which support for BLE. And here, actually, this is the BLE message. BLE message means that the message that we communicate with between the peripheral and the central. So that is the message. We can see the uses of that later. And here's the class ESP32 BLE, and there are several methods: connected and disconnected BLE IRQ, register and send advertiser. I'll explain one by one in short way. So connected is that if the actually this code is designed for just to connect with the BLE and connect with ESP32 using our mobile phone, and whether check it is connected or not. And here I use the built-in LED in ESP32, and it is actually when it's connected to with our mobile phone using BLE, it's that the built-in LEDs its value is always 1, which is it keeps on. And once it is until it is disconnected, and after it disconnected, it changes it state in a periodic manner, so the light is start to blink. So that is what happened when when BLE is disconnected from a mobile phone. or any other device. And BLE IRQ is a BLE interrupt request. So in that request, if there are three events defined here, and if the event one happened, that is going to the if it is connected, that event one happens, which means it is the LED value will be 1 and it stop blinking. And once it is disconnected, it is start advertising. Actually, in in Bluetooth, the advertising part will be done only whether it is disconnected. If the device is keep connected, so other devices, other smartphones or other devices cannot see that the existence of that BLE or Bluetooth device. So only the advertising part is done after the after it is disconnected. So if the event 2 happen, which means if it is disconnected, it is starting to advertise again to nearby devices. And if that is connected, it start to blinking the LED as well. So event 3 is the that we use to communicate with the BLE message with our BLE device and with our mobile phone. And here they are actually the registration codes, UUIDs that we should use in our when you are programming our BLE device. And these are the other important two methods that this one is that advertising part, that it advertise the nearby devices using this method. And the other one is send the method that we use to communicate between ESP32 and our mobile phone. And so this is the main part. Actually, if here we use the button as an input device input, and if the button it depend when it connect the LEDs on and off will be status LED status. We should cover we should handle that using the built-in button in ESP32. But it once we can find the status of that using our mobile phone. And once we press that button, it changes the LED status, as you can see. And it gives an output to our Thorny shell as well. And other output is that message is also sent to our mobile phone as well. For that we use this syntax BLE.send. So that is that basic thing how we connect connect our ESP32 with our mobile phone. And here's the terminal that I used, serial Bluetooth terminal. It is in a Play Store. Actually, it is only in a Play Store. I couldn't find that in App Store. So there's another one called Devil, but actually in my case it doesn't support actually for that ESP32. So I use this serial Bluetooth terminal. This is how I connected with that. I use the read LED command. We can add buttons here. So that's how I connected this one. So after that, we can move to how we can handle commands, BLE commands in MicroPython. For that, actually, the other part is the same. How we connect the LED. And here you can see that I defined another LED, not a built-in one, as pin 15. And this is actually I couldn't explain that before. This is the name that it used when it is advertising ESP32 BLE. This is the advertising name actually it used. And this is as same. This is for the built-in. This is for the built-in LED. So this is the main part of our code. So if the BLE message is on, the light value is 1. So we can control the LED using our mobile phone. It is not as the previous project. We can control that. Not only checking the status of the LED, we can also control that LED using our mobile phone in this way. And Also, here this is a small video that I created for uh, how I run that code. Sorry for the quality of this video, because I have to reduce the quality to upload it to Notion. Just take a look. So as you can see, it is the built-in LED start blinking here, and it stopped blinking once we connected that with our mobile phone. You can see that, and here we can I added two other buttons as well, on and off. We can control that LED using our mobile phone. Just here. Uh, so that's it. So for that, after that, I improvised that code to control our 𝘉𝘭𝘶 using BLE, and uh, uh, this is how the our part is same, and I changed the advertising name, and yeah, actually I used the BL message forward, and it start moving forward and backward, and I connected that with the coding methods in the 𝘉𝘗𝘶 module, 𝘉𝘗 library, and it we give that message to the 𝘉𝘗 using Bluetooth from our mobile phone, it works accordingly uh, to this command in our 𝘉𝘗 library. So I have added all the movements that it can do, forward, backward, and right other things. So actually I when I run this code while connecting that to the computer, it worked perfectly. But after when we without connection by its own power, it lost its connection within a few seconds. So that's the issue with I'm facing right now. So I try to find a solution for that as well. And after that, we can control our using that completely. And as for the back presentation, as for the references, I used that our source code for connect BLE using this link. You can find that, and another useful resource was that your MicroPython Bluetooth library, that documentation. You can find that in the internet as well, and another some YouTube videos helped me to get that resources. And there's that useful book, Intro to Bluetooth Low Energy by Mohammed of Afana, that actually simply explain how the Bluetooth works, and all the architectures, and all the other things about related to Bluetooth Low Energy, not use how to use that using MicroPython, how actually the Bluetooth Low Energy works, and it would very useful to give and get an idea how to connect, how to actually develop that Bluetooth Low Energy in our IoT projects. So thank you very much.